Hello and welcome. Today we're in Math 76 and we're doing chapter 4.3, multiplying and dividing fractions. So when we multiply and divide fractions, we multiply the numerators times each other, we multiply the denominators times each other, and then, if possible, we reduce. So right here, I'm going to say this is equal to 5 times 2, 2 times 5, all over 3 times 7. 2 times 5 is 10 over 21. And then we see if it's in lowest terms, if they have any common terms. 10 is even and 21 is odd, so I can't use 2. I could try 3. 3 doesn't go into 10. 4 doesn't go into 10. 5 goes into 10, but 5 doesn't go into 21. So I'm pretty much at the end of my list. So I'm already in lowest terms, and we worked on lowest terms today in class on Tuesday. So we're going to keep going from here. Number 2, I'm going to multiply my numerator terms by each other. 3 times 1 gives me 3, and 8 times 2 gives me 16, and I've got that negative sign. Again, just like before, a negative times a positive is a negative, and I ask myself, can I reduce this at all? 3 is odd, so 2 doesn't work. 3 doesn't go into 16, so that doesn't work. So I am in reduced form. Okay, I got another one with number 3, 10 times negative 3. So 10, I can think of it a couple different ways. I can think of it as 10 over 1 times negative 3 over 5. And I can reduce this if I can multiply through and then reduce. We'll show that way first. So I get negative 3 times 10, negative 30 over 1 times 5. And you could just use your calculator and reduce this here. And I would go negative 30 over 5 equals negative 6. Now I could look at this and I go 10 is 2 times 5. So I could say 2 times 5 times negative 3 all over 5 times 1. And here my 5's cancel. And I would be left with negative 6, which is the same answer either way. You do it how you like to do it. They're both good. Okay, let's look at number 4. I'm going to multiply my numerators times each other. Get 3 times 5 times x all over 4 times x, y. And I have x in the numerator and x in the denominator, so those cancel. And then I'm left with 5 times 15, 5 times, I just blurted the answer. 3 times 5 gives me 15. And in my denominator, I have 4 over y. I can't reduce anymore because 4 doesn't go into 15. And it didn't say to write it as a mixed fraction, so we're going to leave it right like this. Okay, now we're talking about dividing fractions. Dividing is very similar to multiplying. We keep the first one, and then we flip the second one, and we switch our sign. Okay, so I'm going to keep the first one. I'm going to keep my first term. I'm going to split my sign to multiply, and I'm going to flip my second fraction, so it becomes 8 over 5. And now I'd like to simplify, and this is the way I like to do it, so I'm going to show this. So I look at this and I go, it's going to be 3 times 8 over 4 times 5. And I ask myself, can I factor out 8 at all? Let's think. That's 3 times 8. It becomes 4 times 2 all over 4 times 5. Well, lo and behold, my 4's cancel. And I'm left with 3 times 2, which equals 6 over 5. And I'm done right there because I can't reduce that any further. Okay, let's look at number 7. And then I'm going to erase what I have over here, and so I can have more space. So I've got negative 2/3. I keep the first one divided by 4. Okay, but 4 is really 4 over 1. Okay, so now let's change this division to multiply. So I get minus 2/3 thirds. That doesn't look like a fraction line. Let's try that again. Minus 2 thirds times, I'm switching my sign, and then I'm flipping my fraction, 1 over 4. And I see I have a 2 in the numerator and 4 in the denominator, so I'm going to rewrite 4 like this. Negative 2 times 1 over 3 times 2 times 2. Now I want to cancel. I've got a negative 2 and a positive. So what I'm going to do, this is my little trick. I cancel just my 2, and see, I leave that negative sign right there. And I get 1, negative 1. And make sure I keep my negative sign because that did not get canceled, over 3 times 2, which is 6. Negative 1, 6 is my final answer. Okay, I am going to erase over here so I have more room again. Okay, let's look at number 6. 7 divided by 2 thirds. Okay, so I'm going to keep my first one, 7 tenths. I'm going to switch my sign, times, and then I get 5 in the numerator, 2 in the denominator. Awesome. And now I notice that I have 5 going to be in the numerator, 7 times 5, all over 10 times 2. But before I can multiply through and cancel, but I'm going to see if I have any factors first. I'm going to write out all my factorizations. Got 7 times 5, and 10 is 2 times 5 times 2. My 5 cancels in the numerator and the denominator. And then when I multiply out, I get 7 over 2 times 2, which is 7 divided by 4. And 7 divided by 4 is my final answer. Okay, let's take a look at number 8. Okay, I'm going to keep my first term, mn over 6, and my divide becomes multiply, and I get 3m over n. And I can see I'm going to have some stuff that gets canceled. I've got an n in the numerator and an n in the denominator, and my n's cancel. So now I'm left with 3 times n, m times m, all over 6. Okay, can I factor out my 6? Yes, that becomes 2 times 3. 3 my numerator, and m times m. What's that? Let's remember exponents rule. I've got my base is m, and my exponent is going to be squared. This definitely escalates in difficulty quick. And then my 3's cancel. So I'm left with m squared all over 2. That's my final answer right there. Okay, got to keep going. Okay, I've got a multiply and divide symbols in this section, and we have to figure out what to do. So I'm going to break apart my terms, each number, and I'm going to see what things I can cancel before I multiply through, because it just makes my life easier. So I've got 20 times 14 all over 21 times 15. Okay, let's break up my terms. Okay, first I've got, let's do 20. Okay, I'm going to rewrite this in these colors. So 20 times 14 all over 21 times 15. Okay, so let's look at our factors. My factors of 20, okay, I'm going to break it up with, and I'm going to guess, but I'm going to go 5 times 4 to start. If I have to break up the 4 more, I can do that later. My factors of 14 become 7 times 2, and then 21. My factors of 21 are 7 times 3, and my factors of 15 are 5 and 3. Now I'm going to see if I have any canceling. I notice I have some sevens that might cancel. Okay. So my sevens cancel. Oh, so a good color? I'm not sure. Sevens. And I also have a 5 in the numerator and 5 in the denominator. Those cancel. So now I'm left with over here, I get 4 times 2 all over 3 times 3. Now I don't have anything else I can cancel, so I can multiply out. 4 times 2 is 8 over 9. And I know there's something really important here. My first term, when I'm multiplying through, one is a negative and one is a positive. And I didn't carry my negative sign throughout. So I have to make sure I carry my negative sign throughout the whole process. And it comes to the end. If you look at the end and you say, well, that doesn't match my beginning because I've got a nerd and I've got a preppy person together, a popular person, then that's going to be a negative party experience. Then I've got to make sure that it matches. That's how we check our work. Okay, got another one. 6 divided by negative 2/3. I'm going to write 6 as 6 over 1. So 6 over 1. And then my divide, I'm going to change that to multiply. And I'm going to flip the sign and it becomes negative 3 over 2. I flip the second term when I switch the sign from divide to multiply. And then I'm going to see if I can split up anything and cancel. Okay, so I've got 6. I'll make 6 black. So 6 is 3 times 2. And then times negative 3. We're going to times negative 3 all over 2 times 1. I'm just going to write 2 because we don't need the 1. And I'm going to see if I have anything that cancels. Let's see. That cancels. And I get 3 times negative 3, which gives me negative 9. Now, when we divide by a fraction, it always gives us an answer that we feel unintuitively about that's probably wrong, right? When I look at this, I think, well, it'll be smaller than 6, but it ends up being bigger because we flip it from multiply to divide, and then we flip our term or from negative 2/3 to negative 3 over 2. So we flip those. Okay. 3/5 of 35. Okay, 3/5 of 35. Of in math means multiply. So I've got 3 over 5 times 35 over 1. Oops, make 1 black. Okay. Now I can't factor out 3. 3 stays the same. 35 becomes 5 times 7 all over. 5 stays the same. And my 1, I'm going to leave it out because 5 times 1 is the same as 5. And then I see if I can cancel anything. And I can. My 5s cancel. And I'm left with 7 times 3 or 3 times 7 over 1. And I can reduce that. That becomes 7 times 3, which is 21 all over 1, or just 21. I know it's a lot. We're doing good. And the best way to get better is practicing. Okay, this one's big. We got this. Okay, my first term, 8x squared divided by 1 multiplied by 4x, because I'm switching it to multiply this symbol. So that means I've got to flip this. So my 4x in the numerator goes down to the denominator. And then in my numerator, I have 7. Okay. And now I'm going to see if I can break these down. Can I factor out 8? Yes, I can. 8 becomes 4 times 2. And x squared, remember this is the same as x times x. So I'm going to write it out in expanded form because I think that's going to help. And I get times 7. And then all over 4x. I'm going to leave out my 1. So I get 4x in my denominator. Now let's see if we have anything that cancels. I've got a 4 and a 4. And I've got x times x in the numerator. So one of those x's is going to cancel with one of the x's in the denominator. And now I'm left with 2 times 7, which gives me 14 times x. And I canceled everything out of my denominator. That does not mean that my denominator is 0. I've got this hidden times 1 here. Otherwise, that would be weird because it's still times 1. So this is still divided by 1, which I can simplify to just 14x as my final answer. And now I've got some word problems. Okay, we can do it. I believe in us. A recipe calls for 3/4 cup of sugar per batch of cookies. If Mia wants to make 2/3 of the recipe, how many cups of sugar does she need? Okay, so of tells us in math multiply. So she has 3/4 of means multiply of 2/3. Okay. So this is one I'm going to multiply out, and I'm going to see if there's anything I can do that can cancel. I do notice there's a 3 in the numerator and 3 in the denominator. And let's say I just kept going from here, and I went up, then I get 2 times 4. Well, I know I'm not quite done because I've got an even number in the numerator and even in the denominator, so I need to break this up. So I get 2 times 1 over 2 times 2. And I see if I can cancel. I've got some 2's. And this becomes 1/2. Okay. A piece of ribbon is 7/8 yards long. If it is cut into pieces that are each 1/4 inch long, how many pieces can be cut? Are there any pieces left over? Okay, so we have to decide first, is this multiply or divide? Okay, is it multiply or divide? Well, let's think. We have a piece of ribbon, and this ribbon is 7/8 yards. 7/8. Okay, so it's 8 pieces over here total, and 7 over here. So I'm gonna try and make it look good. Let's count, make sure I did this right. 1, 2, 3, 4, 5, 6, 7, 8. They're not even, but there's 8 total. And the shaded part, I'll make it green. I'll make it fancy. The green part is this beautiful ribbon. And she wants to cut it up into 1/4 yards long. Okay, so we have to ask ourselves, she's going to cut each of these up into pieces. Okay, so she is going to be multiplying or dividing. What do we think? I'm going to be taking each of these, and I'm going to take this new, my whole ribbon, and I want them to be 1/4 long. Okay, I'm going to draw a new picture underneath, one that's a little less ribbony. She wants each of these pieces to be 1/4 long. So she has same 1 foot of ribbon, and she's going to cut them into these quarter pieces. Object's not drawn exactly to scale. Okay, and she's going to go through and she's going to cut and see how this compares. This is a division problem because she's dividing this into subsections. So she's going to take what she has, 7/8, and she's dividing it into 1/4 pieces. I know it feels weird to say, but we think about the problem and we know it's division. Okay, and also when we're cutting stuff up, usually that's also division. Okay, so how do I solve this? Just like I'd solve anything else. I keep my first fraction, 7/8. I change my multiply to divide, and I change my second fraction. It flips, and I get 4/1. Okay, I'd like to see if I can simplify it all. I get 7 over. Does 8 break down at all? 7 does not. 8 is 4 times 2 times 4 times over 1. And my 4's cancel. So I'm left with 7 over 2 times 1, or 7 over 2. Okay. Now 7 over 2, we got to ask ourselves, how many pieces is that really? 7 over 2. Can we make this into a mixed fraction? Okay, I'm running out of the room, so I got to erase my pictures of my ribbon, which was stunning. Okay, I think that's good enough. Okay. There we go. Okay. 7 halves. Okay. I got to break that up. I can use my calculator on this one. I can say 7 divided by 2. And if I do it in my calculator, I could do 7 divided by 2, and that will give me 3.5. Or I could ask myself, how many pieces in 7 over 2? If I've got halves, 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 halves. These are each half pieces. 7 over 2. That's 1, 2 pieces. 3, 4, 5, 6, 7. I get 1, 2, 3, 4, 5, 6, 7 pieces. And I've got 1 whole piece, 2 whole pieces, 3 whole pieces, and a half. So I've really got 1 plus 1 plus 1 plus a half, which gives me 3 and a half, which I'm going to write up here in my other room, 3 and 1/2. So she has half a piece left over too. We will practice more of these because these are not intuitive. So don't be discouraged, and I know you can do it.